So today we did lesson 5, which was equations and their graphs. Previously we did equations and their solutions. Nathan, away. Um, Equations and their graphs, equations and their solutions. Before that, we were making equations from situations and solving them. We're now finally getting into like linear aspects of it. And this unit is called linear equations and inequalities. So like linear is going to be super important this unit. When you hear the word linear, what does your mind go to? Or what should it go to?
A line that splits the graph.
It is. If we go straight up, straight down, it would just be straight across. Sometimes kind of like lifting out, so not perfectly aligned. But yes, you should think of straight lines. I heard something about slope. What's the equation for linear equations? Okay, I'm really glad you guys know that because I didn't even talk about that today. So that should be something you guys learn in middle school, but it is also a big part of ninth grade. By the time you leave ninth grade, you need to know how to identify linear equations from graphs, equations, and tables. So very important. Today we taught you how to graph with graphing technology. So once you have the equation, graphing it with graphing technology is super easy. Now, whatever graphing calculator you plan to use for your state test, like please learn how to use it. Desmos you do not get for your state tests, but Desmos is really helpful for like your unit tests. You'll at least have it for that. And here's an example of something in slope intercept form. All you have to do is like type it in and it graphs it for you. It lets you click on certain features of the graph that are important, like your y-intercept, your x-intercept. It lets you click on the line and drag. Everything that's on the line would be a solution to that equation. So like, let's just pick a random one, even like a decimal. 1.8 and 1, I'm sorry, I need to remember this. 1.8, 4.6. Okay. 4.6. Okay, I kind of just typed it here so that I could remember it. But this side of the equal sign, when I simplify that, it does equal 4.6. It does give me something that is true for this equation. So everything that's on this line are different combinations that make it true. And then we looked at like certain situations, like real world situations. Real world situations, like maybe their equation will look like y equals mx plus b. Maybe it'll look more like this, which is our standard form. I just made one up. But you see it still makes a straight line. It still has spots where you could plug in an x and a y, and everything that's on the line is a solution. Everything that's not is not a solution to that equation. And that was basically what we did today. And some more practice, like with the real world situations. So yeah, that's about it. The other thing that I think would be important, that would be helpful, since Desmos doesn't really read other letters other than X and Y, you might need to figure out in a certain situation what would be X and what would be Y. X is always your what? Independent variable, which if one of them is time, it's usually the X. So I for independent variable, you can make an I with the X axis. D for dependent variable, you can make a D with the Y axis. Whatever depends on the other thing in the situation is going to go on the y-axis because it's dependent. Whatever you can't really change, so yeah, usually time, not always, but usually time, or like number of something, number of students, whatever it is, that will go on the x-axis. And that can kind of help you figure out how to change the equation so that you can graph it and then find the answer. All right, so this is the one that you're all here today. I expect you to get 80% or higher. Let me know if you need more attempts. I didn't check to see if it was available in all your classes, but if it's not, like tell me and I'll make it available. Got questions, let me know. Otherwise, I'll check in around like 12:50 and see what I can help you with on the getting an 80% so far, then I would definitely pay attention to this one. It's number 4 on lesson 5. So we have Priya starts with $50 in her bank account. She then deposits $20 each week for 12 weeks. Determine whether the following statements about the situation are true or false. So we have an equation that represents the relationship between the dollar amount in her bank account, D, and the number of weeks of saving, W. So she's depositing $20 each week. End of line. $20 each week, anytime it's each, every, per what operation is implied. Multiplication. So that 20 should be multiplied by however many weeks. Does this equation allow for that? Is it 20 being multiplied by the weeks? So then that one's going to be false just based off of that alone. The 50 is what she starts with in her bank account. So that should be like the one-time fee that's being added, not the thing that's being multiplied each time. So that first one is false on my screen. The next one, we have the graph below correctly represents the relationship between the dollar amount in her bank account and the number of weeks saving point of weeks. So if we were making the equation, it would have to be 20W plus 50. And this is a linear function. So one, I mean, we didn't really teach you how to graph these by hand, so you probably have to like pull it up in Desmos and compare. That is what we've taught you so far. But though where it touches the y-axis, you can see in the linear equation, and this does follow like slope-intercept form. What is the y-intercept on this? It's y-intercept, so where it touches on the y-axis. I think you're talking about the point 3. I'm talking about where it touches on the y-axis. Where does it touch on the y? So like a little bit above 40, so 50. Yeah, so that I can see from my equation that we just made to represent the situation. 50 should be the y-intercept, so far that's looking good. And with each week that goes by, it should look like they're adding 20. So like they started with 50. After 1 week, that would bump them to like 70. That does look like a 70 right there. After another week, that bumped them to 90. Like this does look like it's matching that pattern so far. And then it has the point representing the amount after 3 weeks. Well, if you read the labels, like, yeah, that is 3 weeks. So far that looks true for that one. For this one that's down here, it says it takes Priya 10 weeks to have 250 in her bank account, and the point on the graph below represents that amount. So again, we want it to have a y-intercept of 50, which it looks like it does, and it looks like every week they're adding 20 to the y. So that looks good, like it is that situation. And then for the 250, that would be at 10 weeks. That does look like it's at 250. Let me just make sure. Yep. So I would say that that one's true as well. And that's how you get it completely right. Questions on others? Number two. Okay, so we have this equation graphed. Select all the coordinate pairs that represent a solution to the equation. Let's see, I think they're all visible on here, which is good. Otherwise, you'd have to like plug it into the equation and see if it's true, or you could type the equation in here also and then type in those coordinates and see if they touch the line. But they're all visible on here, so I'm just gonna kind of, so that I don't have to like scroll, I'm just gonna make a list. And coordinates always go in what order? Good. So then when I'm evaluating all of these, seeing if they're on the line or not, I need to make sure that I'm looking for the X value that it intersects there and then the Y value too. So like 0, 6, here's where it would go on the graph. Would that be a solution? Good. And then you're doing the same for the rest. 4, 1 would be here. That's also not on the line. 6, 2 would be there. Also not on the line, so it's not a solution. 3, 1 would be here. So that one is on the line. It is a solution. 2, 6 up there. So no. And 0, 2 right there. Yes. So it could be shuffled on yours. Make sure you pick the right ones. But that's how you tell by graphing if they're solutions or not. And don't pick any extra. So questions on this question? Does that make sense, Ella? Good. Okay. So I'll do that right now before I forget. On lesson 5. Okay. Yes. Okay. So for this one, there's definitely a lot of reading. So I'm going to kind of skip ahead to see what it wants. It wants us to match each expression or inequality to the quantity that it represents. So down here, ahead, these inequalities, remember like what they mean. So the opening should be facing the bigger number in the situation. So like this one that says t less than or equal to 30, or 15 less than or equal to t, where t is the total number of players in a game. S less than 80, where S is the score of the team. That means that they're scoring less than 80 and things like that. So I'm gonna go back and read. So we have the allowable numbers of players on a team. When we read this paragraph, we're going to pay attention to how many players are allowed on the team. So we have in a video game, players from teams or form teams and work together to earn as many points as possible for their team. Each team can have between 2 and 4 players. So that information tells me the allowable number of players. Find the one of these that would say there can be between 2 and 4 players on the team. Now, this one has extra numbers, so I'm not going to pick that one. This one says total number of players in a game, not team, so I'm not going to pick that one. This one talks about the score of the team. This one has a 20, which wasn't mentioned. We want like a 2 to 4. So the process of elimination, it must be this one. But it makes sense because it says P is the number of players on a team, and P has to be greater or equal to 2 and less than or equal. Does that make sense? So like, that's how you're gonna. That one goes there. Then we have the number of points Han's team earns in one round if every player earns a perfect score. Now, let's see if it says how many players are on his team. Okay, Han and 3 of his friends. So there's 4 players on Han's team. And it says each player can score up to 20 points in each round of the game. So in one round, if all 4 people score 20, how many total is that? Good, so then I'm looking down here. Now don't get confused with this one. That one has an 80 in it, but it says it has to be less than 80. If they're scoring 80 exactly, it's gonna be this one because 4 times 20 is 80. And that's the math we just did to get that. Each player scores 20 points, which is the most they could get. That's what's in there. Right, then we have the number of points Pon's team earns in 1 round if no players earn a perfect score. So we know a perfect score is 80. Which of these 3 options would be the one for that one? S less than 80, where S is the score of the team. All right, and then now we're just down to 2. So we have the number of players in a game with 6 teams of different sizes. 2 teams have 4 players each, and the rest have 3 players each. Okay, so 2 teams have 4 players each. That, and then the fact that out of the 6 teams, if 2 of them have 4 players, that means 4 of them are left. We have 3 players. So that's going to be this expression here. That's going to give us an exact amount. So then process of elimination, this one must go with that one. And that's the possible number of players in a game with 8 teams. And let's see, T is the total number of people in the game. 8. We said that, I don't know why it's like numbered so, but I mean, it's the only one that's left. We can have 2 to 4 players on each team, so 2 times 8 is 16. So it has to, that's why they're doing, I don't know why they're doing equal to 15, but they have to be greater than or equal to 16, I think. And then 4 times 8 is 32. So I don't know why they're doing 30. This is the only one that makes sense. All right, question for this one. I have time for one more. Any other question? Sarah?
Did you already do number 2?
Let's see. We did. We don't have time to answers. So if the coordinate is on the line that's graph, like not the axes, but the line that's graph, then it's evolution. If it's not, then it's not. Is there one in particular you were confused about? Please.
Well, when I picked first time, I picked 2, 6, 6, 2, and I think it was 4, 1. And then I got those all wrong. And then the next time I picked the last 3 and it said they were all.
Okay, so it could be shufflable, so I don't know what the last thing would be. But so like 6, 2 would be here where my finger is. 6 on the X, 2 on the Y, so that's off of the line, so that's why. Over here, I think you said 6, 2. 6, 2 would be up here, so also off the line. Right, so like the first number is always the X, so find it on the X axis. Second one's always the Y, see where they like intersect. And then there should only be 2. I think it's always. I did record this, so if you're still stuck on it later, because